because astronomers have hit the jackpot. This is their dream come true. A new chapter in astronomy has opened up. And about 1/5 or so of them have Earth-sized planets going around them.
When theoretical physicist Michio Kaku made his unexpected revelation about Proxima B, the world collectively held its breath. Known for his visionary interpretations of advanced physics and his deep interest in the possibilities of extraterrestrial life, Kaku's announcement was anything but ordinary. This time, he wasn't speaking in hypotheticals or distant probabilities. He was addressing something tangible, something confirmed. His words reverberated through scientific communities, media networks, and global populations alike. Proxima B, the Earth-sized exoplanet orbiting the red dwarf Proxima Centauri just over 4 light-years away, had just yielded undeniable signs of alien life. Before we start, smash the like and subscribe buttons for more updates. The excitement wasn't rooted in vague speculation or ambiguous data like past claims had been. For years, astronomers have eyed Proxima B as one of the most promising candidates for life beyond Earth. Its location in the habitable zone of its star and its Earth-like size gave it an initial boost in credibility. However, conditions on red dwarf orbiting planets are known to be volatile. With Proxima Centauri being a flare star, many scientists worried that any atmosphere on Proxima B would have long since been stripped away. That concern loomed for years, until now. Kaku's announcement was built on a foundation of data collected from several deep space observatories, including the James Webb Space Telescope and the Atacama Large Millimeter-Submillimeter Array ALMA. What made this discovery so profound was the detection of a series of atmospheric biosignatures, chemical compounds that strongly suggest the presence of biological processes. The readings included a stable mix of oxygen, methane, and an unusual compound combination that, under normal planetary conditions, would rapidly break down unless continuously replenished by active processes. Those processes, Kaku asserted with conviction, were biological. The atmosphere of Proxima B, once assumed to be lifeless or non-existent, was now confirmed to be dynamic and balanced in a way eerily similar to Earth's. This was the pivotal moment in his revelation. The clarity with which the biosignatures pointed not just to the potential for life, but to the active presence of it. The implications were staggering. The composition of Proxima B's atmosphere simply could not be explained by abiotic processes alone. There was something living, breathing, metabolizing on that distant world. Even more compelling was the discovery of a faint but regular thermal pattern on Proxima B's surface. These thermal signatures suggested localized temperature regulation. Again, something extremely difficult to explain through non-living means. It was as if certain regions of the planet retained heat while others radiated it more readily, a pattern consistent with both primitive and complex life forms managing their immediate environments. Kaku highlighted this as a key piece of the puzzle, supporting the theory that ecosystems might exist in pockets across the planet's surface. Beyond just the atmospheric and thermal data, spectroscopy also revealed signs of surface reflectivity that changed rhythmically in sync with Proxima B's 11.2-day orbit. These fluctuations hinted at the possibility of vegetation-like structures or biological colonies reacting to light and dark cycles despite the dim output of Proxima Centauri. Life, it seemed, had found a way not only to exist, but to adapt and thrive under conditions previously believed too harsh or erratic for biology as we know it. Kaku's revelation stirred a deep philosophical current. For centuries, humanity has asked the question, are we alone? That question has driven explorers across oceans, astronomers to the stars, and thinkers into the deepest realms of metaphysics and theology. Now, with the veil lifted, if only partially, by this discovery, the answer seemed closer than ever. The realization that we are not the only living beings in the cosmos shatters the illusion of cosmic solitude. Suddenly, all the philosophical musings about humanity's place in the universe demanded reevaluation. Life had emerged independently, light years away from Earth, in an entirely alien context. That made one thing absolutely clear: life is not an anomaly. It is a cosmic imperative. There was no need for sensationalism. The gravity of the findings spoke for itself. The presence of life on Proxima B altered the entire trajectory of science and human identity. This wasn't about little green men or flying saucers. It was about microbial or even multicellular life that arose in parallel to us, with its own evolutionary path under a red sun so different from our own. If it happened there, it could happen in thousands, millions of other places across the galaxy. Kaku emphasized that while Proxima B's life was unlikely to be intelligent in the human sense, no cities, no radio signals, no technological signatures, it was the purest kind of alien life we could have hoped to find. It was untainted by Earth's biological history. It represented an evolutionary tree completely distinct from our own, a separate experiment carried out by nature in the vacuum of space. And perhaps in that independence lies the greatest treasure of all, the chance to study how life can arise under drastically different conditions, giving us unparalleled insights into biology, evolution, and perhaps even the origin of life on Earth. The announcement also illuminated the sheer audacity of nature. Proxima B is bathed in the radiation of its turbulent host star, experiences extreme magnetic activity, and is likely tidally locked, meaning one side constantly faces the star while the other remains in perpetual darkness. Yet life emerged there, somehow in regions that might exist in the twilight zone between the burning day and the frozen night. Nature found balance. This equilibrium zone, known as the Terminator region, may harbor lakes of liquid water, fertile soils, and now confirmed, active biospheres. Kaku was careful to point out that while the discovery was monumental, it wasn't a fluke. It was the result of years of coordinated research, technological development, and global scientific collaboration. The instruments that made it possible were operating at the cutting edge of human engineering, and they delivered data of unprecedented clarity. Spectrographs capable of analyzing the molecular makeup of alien atmospheres with pinpoint precision, and telescopes sensitive enough to detect subtle heat emissions from planets trillions of miles away, had together unveiled the secret that Proxima B had kept for eons. This moment also marked a technological triumph. Humanity had reached a stage where its eyes and instruments could detect the breathing patterns of a world 4 light-years distant. The data was not just statistical noise or interpretive suggestion, it was precise, repeatable, and confirmed by multiple instruments across different observatories. The biosignatures lined up, the thermal signatures matched, the spectral shifts were consistent. Each piece of evidence on its own might have been questioned, but together they formed an undeniable picture. As the implications unraveled, questions about the nature of this life began to flood the scientific discourse. What are these organisms like? Are they single-celled? Or have they evolved into more complex structures? How do they metabolize? What kind of biochemistry sustains them? Do they rely on carbon and water, as Earth-based life does? Or are they based on a different chemistry entirely, perhaps silicon-based, or using solvents like ammonia or methane? The data suggested oxygen and methane, hinting at familiar biochemistry, but without direct sampling, the specifics remain tantalizingly out of reach. What this discovery also shattered was the anthropocentric view that had, in many ways, defined scientific exploration. Humanity had long assumed a special position in the cosmos, either as the lone cradle of life or as its pinnacle. The confirmation of life on Proxima B didn't just challenge that, it demolished it. Here was evidence that life, far from being unique to Earth, could arise independently given the right ingredients and enough time. The conclusion was inescapable. The universe is not lifeless. It is likely teeming with life, hidden in countless forms across planets circling distant suns. This event ignited renewed vigor in exoplanet research. Proxima B became not just a point of scientific interest, but a symbol. Its discovery reinvigorated a sense of wonder and purpose in fields that had been cautiously speculative. Planets once overlooked as too hostile or too distant were now being reconsidered with fresh eyes. Astronomers were no longer merely hunting for habitable zones. They were seeking biosignatures, living worlds, active systems. And they had a roadmap now, one built on the lessons of Proxima B. The search for extraterrestrial life was no longer hypothetical. It was empirical, real, alive. With Kaku's confirmation, humanity had taken its first definitive step into a broader biological cosmos. The implications for astrobiology were vast. The genetic study of alien organisms could one day reveal entirely new mechanisms of inheritance, resilience, and adaptation. Biological systems not seen on Earth might be found to function in extreme environments, broadening the scope of what life is and could be. Educational institutions around the globe began revisiting their curricula. How does one teach biology when Earth is no longer the only template? What does evolution mean when considered across multiple planets, multiple ecosystems, and potentially multiple biochemistries? New fields would inevitably emerge: xenogenetics, comparative astrobiology, evolutionary cosmology, all born from the realization that life is not unique, not confined, but universal. Religious and cultural interpretations of the event varied widely, but even in the midst of diversity, a shared sense of awe prevailed. Whether seen as a reflection of divine creativity or as the majestic impartiality of nature, the discovery stirred a reverence for the universe's intricacy. The realization that other life existed, and perhaps had always existed, brought with it both humility and inspiration. Michio Kaku's revelation about Proxima B didn't just confirm alien life, it changed everything. It forced a paradigm shift that extended far beyond astronomy or physics. It reached into human identity, consciousness, purpose. If there is life there, what about elsewhere? What forms might it take? Could intelligence evolve under those red skies? Could civilizations exist that are older, wiser, perhaps unaware of us just as we were unaware of them? And if life is as common as this suggests, then where do we go from here? This is where science transitions from observation to aspiration. Proxima B, now known not just as a planet but as a living world, has become the North Star of a new generation of exploration. It beckons researchers, thinkers, and dreamers to reach beyond what once seemed impossible. The moment of confirmation is now behind us, and what lies ahead is the unfolding mystery of what else the universe has kept hidden, waiting only for us to find the tools and the will to see. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Proxima B revealing alien life? Will disclosure happen? We want to hear from you. Thank you for watching, and see you next time.